Every night, human beings engage in a strange biological contradiction. We instinctively bury ourselves under heavy blankets to create a warm, cozy microclimate, yet our bodies strictly require a shockingly cold room to actually fall asleep. Sleep researchers and clinical guidelines consistently point to a very narrow, cool window for optimal rest, advising that you keep your bedroom thermostat set exactly between 65 and 70 degrees Fahrenheit. Look at what we actually do right before bed, though. We take hot baths, put on thick pajamas, and wrap ourselves in heavy duvets, intentionally building tiny heated nests. Why do we do this? Why does human biology actively demand a cold environment, while human behavior instinctively builds a hot one? The answer comes down to thermodynamics. Sleep is an active mechanical process driven by a single biological imperative. Your body must shed its internal core heat. To understand how this works, we have to divide the human body into two distinct thermal zones that act independently during the night: the internal core, where your organs reside, and the external skin. Exactly 2 hours before you fall asleep, your circadian rhythm, your internal 24-hour biological clock, dictates that your internal core temperature has to drop by approximately 1 degree Celsius. To make that drop happen, the body relies on the distal to proximal gradient. This physiological mechanism warms the skin of your extremities, like your hands and feet, forcing the blood vessels near the surface to dilate and widen. This turns your skin into a biological radiator. Dilated surface vessels pull trapped heat away from your internal core to the skin. For that heat to actually leave and avoid being reabsorbed, the ambient room air must be a cool 65 to 70 degrees. Thick blankets and warm baths do not actually warm your core. They prime your skin to dump your internal heat into a perfectly calibrated cold room. As you move through the different stages of rest, your body's ability to regulate its own temperature degrades. During non-REM sleep, that initial drop in body temperature triggers specific protective housekeeping genes that actively repair the brain. REM sleep is entirely different. During REM, the brain paralyzes the body and completely shuts off internal thermoregulation, leaving you defenseless against the temperature of the room. This line chart tracks sleep depth over time, showing deep REM valleys shattering and spiking into wakefulness when ambient temperature crosses the 75 degree or 60 degree thresholds. This biological failsafe protects your body from overheating, but destroys restorative REM cycles in the process. Keeping your thermostat set between 65 and 70 degrees is a structural requirement to protect your brain during its most vulnerable state. Because REM and non-REM sleep have distinct thermal requirements, maintaining a single static room temperature all night is biologically imperfect. This problem led to the development of adaptive thermal regulation. This is a technology built into smart mattresses that uses AI to dynamically shift the physical temperature of the bed based on your real-time sleep stages. This graph shows exactly how that targeted intervention works. Notice the orange mattress setting temperature line actively dipping into a physical trough, specifically during the highlighted REM sleep stage zones, dropping to exactly 30 degrees Celsius at the exact moment the sleeper enters vulnerable REM. This bar graph reveals the clinical proof. The green RTA bars definitively outperform the blue control and yellow constant temperature bars in total sleep time and sleep efficiency, proving targeted cooling reduces time to enter REM sleep and increases overall rest. As AI sleep technology advances, the physical law of human biology remains absolute. Heat must escape the core for you to rest. Until you upgrade to an adaptive smart bed, your best biological defense is locking your bedroom thermostat right between 65 and 70 degrees. Sleep is an active mechanical architecture. Keep your nesting microclimate warm, keep the ambient room cool, and you can engineer the perfect night of rest.